Now let us talk about the binary subtractor. Similarly, similar to just like what we did for the binary addition, we can perform the binary subtraction operation, and this is easily doable, right? We have already done it for the half header. We have done it, so we can simply do it for the half subtractor. Half subtractor means if there is no previous borrow, then we can utilize the half subtractor. Okay. So the half subtractor has two inputs x and y and two outputs difference in the borrow. So if you see here, the truth table could be like 0, 0, 0, 1, 1, 0, and 1, 1. And if you try to find the differences of all these things, so what will be the difference? Let us try to see here. Difference will be like if 0 minus 0, difference will be 0, there will be no borrow. Let us talk about the third case. We'll talk about the second case later. 1 minus 0 means the difference will be 1. There will be no borrow. 1 minus 1, that will give you the difference will be 0 and the borrow will be 0. Now let's talk about this second case. 0 minus 1. So that has to borrow, like I have to borrow 1 so that I can make it 1, 0, and then I have to subtract it. So the borrow is needed here. So I need to borrow some of the things. So borrow will be 1, and then 1, 0 minus 1, that will give you the 1. So this difference will be 1. So this is how the half subtractor works. Okay. Now, if I try to make the function for the borrow and the for the difference, so how it will look like? Let us try to see here. If I want to write for difference, so difference will be nothing but summation of minterms, that is 1 and 2, and the borrow is nothing but this is the summation of only 1. Okay, so this is the sorry, m should be there. Okay, so this is the borrow and the difference. Let us try to make the k-map of all these things. So k-map will look like this one. Suppose I want to make the k-map for difference, then 1 and 2 will be there, and we know that this 1 and 2 are diagonal, so directly this is the XOR. Okay, and if I talk about this b, so the b is 1 and I need to keep it here, and if I try to write the expression, so the difference is x XOR y, and the borrow is nothing but this is the x bar y. If you can recall, if you can remember, the full adder in a half adder, in that case the carry was xy, but here we are getting x bar y. Okay, so how it will work, let us see. Let us try to design this circuit. Okay, can anyone tell me how we can design this circuit just like a half adder? Can anyone tell me?
One XOR gates.
One XOR?
Sir, one XOR gate for D.
Yes.
And sir, one NOT gate and one AND gate.
Okay, so we need 3 gates, one XOR gate for the difference, one inverter for the X bar, and one AND gate for X bar Y. Perfect, absolutely correct. Okay, so here, suppose I have a X, I need one inverter to get the X bar, and then X bar will be one of the input of AND gate. Okay, and the second input will be Y, and we need one that will give you the borrow, and we need one XOR gate that will be connected with the X and Y, that will give you the difference, and this is how the circuit will look like. Okay, so this is the circuit for binary subtractor or half subtractor. Okay, if you have any doubt, you can ask the questions, otherwise we can move ahead with the next kind of circuit. Okay, let us try to see. So I think this is quite easy, not that much difficult. Yes, very important thing is as of now, so let us try to make the half adder and the half subtractor. Let us try to compare these two circuits. This is the simple circuit of half adder which we have already studied before. Okay, and just now we made half subtractor, and that looks like this one. If we closely see these two circuits, the only difference is the inverter that is placed at the input X. Okay. So can anyone suggest how I can make a one circuit that can act as a half adder or half subtractor? Can anyone suggest how we can modify the circuit in a such a way that the single circuit can act as a half adder and the half subtractor? Anyone? We have already done these things before.
So we can use a control.
Control, definitely.
Yeah,
So
control X.
component and XOR gate, right? We need control signal and the XOR gate or XNOR gate. Absolutely correct. See here, we know that the property of XOR gate is like, suppose I have XOR gate, and if we have a two numbers, A B and 0 0 0 1 0 1 and something like that, so that used to give 0 1 1 0, and if I am fixing one of the input, that is if it is acting as a control signal, so I am getting it as a inverter. Okay, so I am getting the complemented output, same output. And if the one of the input is connected to logic high, so I'm getting the complemented output. So what will happen? I will utilize one XOR gate instead of this inverter, and I will have one control signal that will decide whether I have to use this circuit as a half adder or I have to use it as a half subtractor. If C is equal to 0, in that case, the circuit will act as a half adder, because if C is equal to 0, whatever the X is there, I will get the same. And if C is equal to 1, I will get X bar. Okay. So, and this is what our requirement is. Okay. So for half adder and for a half subtractor. Okay. So the simply XOR, you can also use the XNOR logic, right? So in that case, the control signal will be changed. Okay. So I will use one XOR gate, that will be the input. Then I will use another XOR gate and then AND gate, and that will give you, like, this will give you the sum and difference. These both are same. So here at this one, I will get this can act as a sum or the difference, but this input can act as a sum. Like, yeah, if C is a control input, C is equal to 0, then it will act as a carry. Okay, and if C is equal to 1, it will act as a borrow. Okay, so this is the case. Now I have to control these things with the help of C. So the simple circuit that can act as a half adder as well as half subtractor. I think doubts are clear. If you have any doubt, you can ask the question. Yeah, similarly, you can replace this with the XNOR. Okay, so this control signal will be opposite. If C is equal to 0, then borrow will be there, and if C is equal to 1, then carry will be there. Okay, so you can use XNOR as well. Okay, so yeah, so this will act as a half adder or subtractor circuit. Now let us talk about the full subtractor design. Okay, how the full subtractor can be designed, let us try to see here. We have three different possibilities, like three inputs from 0 0 0 to 1 1 1. Let us try to see what are the outputs here. If we see here, 0 minus 0 minus 0, difference will be 0, borrow will be 0. 0 minus 0 minus 1. So in this case, the borrow will be generated, and because we are 0 minus 0, so that the difference will also be 1. So that will become 1 0 1 0 minus 1, that will give you the 1. So the difference and borrow will be 1 1. Next case, yeah, this will similar to the previous one, 1 and 1. If you talk about this one, 0, like 1 minus 1, so that will give you the next case. If you talk about 0 minus 1, that will give you the one borrow will be there, and the difference will be like 1, and then 1 minus 1, that will give you the 0. Let me repeat it again. This is a very important case. First I have to perform this one, 0 minus 1, so that I need to borrow something, so borrow will be high, and after subtracting I will get 1, and then I have to subtract 1 minus this one, so 1 minus 1, that will give you the 0. So this is how 0 and 1 is coming. Okay, similarly if you see the other case, I will get 1 minus 0 minus 1, 0, difference will be 1, borrow will be 0, 1 minus 0, that will give you the 1, and then 1 minus 1, that will give you the 0. So difference and the borrow both will be 0, 0, and 1 minus 1, that will give you the 0, and 0 minus 0, that will be the 0, and 1 minus 1, that will be 0. Okay, and 0 minus 1, the borrow and difference both will be 1. So this is how the truth table can be formed. Once we are ready with the truth table, let us try to see how the function will look like. If we talk about the difference, so the difference is given as 1, 2, 4, 7. So this is the difference. If we talk about the borrow will be summation of m, that is 1, 2, 3, and 7. So this is the difference in the borrow. Let us try to make the KMF for the difference. I will take 2 more minutes and I will finish it off, right? So KMF for the difference, that will be something like this. Let us try to see how the KMF will look like. Difference is 1, 2, 4, and 7. So because we have already done it, so I think I don't need to put too much of stress on this. You will be able to understand. Okay. So for difference, I have 1, 2, 4, and 7. So 1, 2, 4, and 7, and this looks like a XOR gate. And for the borrow, we have 1, 2, 3, and 7. 1, 2, 3, and 7. 1, 2, 3, and 7 are here. So I need to make the pair for this. The pair will be like this one in the first one, this is the second one, and this is the third pair which we can form here. Okay, and if we try to write the expression will be like difference is equal to x XOR y XOR z. How it is coming, we have already done it. Okay, and if we talk about the borrow is coming something like, from here I will get x bar z plus x bar y plus y z. So see here, x is again complemented and rest all are same. So if we try to design a circuit, this will be like this. Here we have complemented x and rest all other circuit will be same, just like a half adder. Okay, so this is how we can make the half subtractor, how we can design the half subtractor. Okay, hope points are clear. They are not that much difficult because we have already done it for the full adder. So simply we can simplify it for the full subtractor as well. Only difference between the full subtractor and the half subtractor is this inverter. Yeah, similarly this inverter can be replaced with the help of XOR gate and XNOR gate, and the same logic can act as a full adder or the full subtractor. Okay, so this is how you can do that. Some tutorial question based on that. Design a half subtractor with the help of NAND, NOR, AND or inverter. Similarly, design a half and full both with the help of NAND, NOR, and AND or inverter. So this is the homework that you have to do it.